Hey everyone, in this video, we will go over the two frameworks. One is called Pydantic AI for building agents. The other one is called BAML. We'll compare them. We'll build an agent with it, go over how it works, and then we will look into a library called Temporal. We'll use it with both these frameworks and see how it responds. So this is the whole idea behind this video. This is a web page, so I'll share the GitHub repository as well. I'll put that in the video description. You can check out the repository, you can check out the code. There's a website, you can open that up, and this is what it shows. So this is the flow diagram of the agent and how it works. So if a user comes and asks a question, there's an LLM which chooses the next step. So the next step could be a decision, a decision that it makes about which action to take next. An action could be a tool. So in this case, the tool is search web, the other one is query internal DB, and the next one is final answer. This dotted line, this thinks action, this only happens when you're building the agent with BAML. I'll go over that when we go inside the code, but basically this agent takes in a query. If this query is just a typical web search query, it does like web searches, checks if the answer makes sense. The decision would be web search, it'll get the response from the web search, it'll send it back to the LLM, then the LLM would decide, should I do a web search again, should I do query internal DB, or should I get the final answer. If it received enough URLs and the information was good enough, it'll just say in the next iteration, it would just say send the answer back to the user. It'll finalize the answer and send it back to the user. So this is how agents generally work. So it's just iterative. It's like a while loop. Every iteration is basically an LLM deciding which action to choose, execute that action, look at the response of that action, choose what to do next. Maybe if the answer is ready, give it back to the user. So that's the whole flow. So that was just like web search focused. If the query is about the company itself, it has to look into the internal DB. So it comes here. The decision would be query internal DB. And here I've added a human in the loop step. So every time this agent has to look through the internal DB, it has to take an approval from the user. If the user says yes, it writes a SQL query and queries the DB, gets the answer back, sends it back to the LLM. So the same flow at the end of the day. But I just wanted to add human in the loop here. So that's the difference. If it says no, it would record that as a denied action and send it back to the LLM. So the LLM can decide what to do next. So that's the whole flow of the agent. I have built it using BAML as well as Pydantic AI so that we can compare the differences. But basically Pydantic AI is a framework to build agents. It's a Python focus, while BAML is a code gen tool chain. You write your agent using BAML and then it creates these compiled files, and you can use them with any other languages. You can use it with Python, you can use it with TypeScript, you can use it with Ruby. So if you're building agents in other languages, you don't have to stick with Python. That's why I wanted to compare these two frameworks. So BAML is a good choice there. So that's about the languages, and then we'll go over the code. So that's why I'm just scrolling by. The prompting, we'll go over that as well inside the code, how the prompting is done in both the frameworks and how it compares. And then the tool and the function calling as well. So BAML it's pretty Pythonic how it's written. And while Pydantic takes care of a lot of things, you just use decorators. So that's the difference there. And then the structured output. Both are pretty good at giving you structured output. You define everything you need from each of the tool calls, from the LLM, how structured you want it. We'll go over that. And the streaming bit, we can skip that for now. Human in the loop, I'll show that to you guys. Yeah, you can check this out in more detail when you go over it. But these are the main points. Okay, so let's run it first, and then we will go over the code. The agent setup, what I'm gonna do is, let me run a simple example of exploring what are our Q1 product launch results. So since this is company specific query, it has to look in the internal DB, and so it should come back and ask us for permission. Right now I'm running the BAML agent. So if you see what happened here, the query went in. I have given this stop condition, if it goes through 6 iterations, just stop there, and it comes back. It decides the action should be query internal DB, and it gives the rationale, and the topic should be product. So when I'll show how the DB is set up and why it shows the topic as product, but I can say yes here. and it should be able to like query the DB and give us the response back. Does this make sense? So it gave the answer back. The answer is structured this way because we have given the structure inside the code. So let me go into the code for BAML. So this is, if you look at the GitHub repository, this is the BAML example. Like I was saying, these are like the compiled files. You just need to focus on these particular files. So let me just go over. So this is where we define the main prompt. Okay, we define a function called chat, and it should choose the next action. Okay, and we have given this prompt: you are a research assistant, choose the next action to take. We describe the next actions, like what are the options: search, query internal DB, think, which was only BAML specific, record a reasoning step before acting. It's just to like add reasoning into the loop. And then rules that it needs to follow, like cite the sources when you're replying to the user. And like I was saying, I was showing this in the website, like how the prompting is done. BAML, we use Ginger for the prompting. So this is like dynamically filled in. As the iteration happens, it like adds the conversation till now. So it like iteratively happens automatically. We go into the client, we're using GPT 5.2 model, and then let's skip the test for now. These are like the types. So this is where you define the structure. So what the citation structure looks like, what the message structure looks like, what are the tool results like. So the search web action, if it chooses like the search web action, it has to give the query also. That's how we can like query, use the SERP API to query the web, and then the rationale as well, like why it chose that. If it chooses query DB, it has to give us a topic. So it gave us the topic product in this particular example. And then if it chooses think action, just like the thought string, what it thought, and then a reply to the user, it has to reply in this format. And that is why, so it has the action type, answer, citations, and confidence, right? So that is why in our terminal, this is why it looks like this, you know, it has the answer, it has the confidence, it has the citations. So exactly that format. So if we go back and go through the whole loop, so this is pretty much the loop. So if you see, like I was saying, the while loop, that's how agents work. So in this case, it's like a for loop, and the condition was maximum turns over 6. So if it reaches that turn, it would stop. And it's the same thing. It has the chat function that we defined earlier, in which it chooses the next action. And then there are a bunch of if conditions. If the action is this, I have to do this. If the action is this, I have to do that. So if it's query internal DB, it like looks for approval. So it runs the approval function and like checks if it was approved or not. And then if it's think, it's just like a simple LLM call with what has happened till now. If it's reply to the user, it has to reply in this format. That's pretty much it. This is how the query comes in through the terminal. This piece is only needed because I have two kinds of code. Like one is like what will happen if we're using temporal and if we're not using temporal. And I'll go over it next. Let me just cover Pydantic AI first. So let's go back to our terminal, clear this up, and run the same with Pydantic. So we're using the same model. It has the same tool call limits as 6. I'm gonna say yes. So this is the answer we got. So if we go back to the code now, let me minimize this. Let's go into the Pydantic example. So in Pydantic, it's a framework which is meant for agents, and it has a lot of contributions. So it's pretty good. It supports building agents when you're using Python. So it has a lot of functions already to support you with that. So if we go into the agent file, this is where the prompt is defined. So again, like you're a research assistant, these are the tools that you have access to. This particular tools requires human approval. Strict rules you need to follow. Only like query internal DB when the user asks about internal/company matters. You don't have to like query internal DB if a person is asking about San Francisco or something, you know, very generic. This is a build agent function that they have. This is where you pass in your model, system prompt. This is where you define all your tools. So this is the decorator that you use for the tools. You have the search web tool, you have the query internal DB tool right here, and then you have the run agent. So inside the run agent, there is the limit, the stop condition that we defined. And then this one is pretty much this while loop with this condition is pretty much to like if there are tool calls which are conditioned on human approval, let's go over that and finish that. So it keeps on checking, it like runs those deferred approvals, figures out if they're approved or not, and sends it back to the LLM. So all of this like deferred tools and stuff, like these are imported right now in this file. So like Pydantic AI has all of this defined already. We didn't have to define any of these things ourselves. While in BAML we had to. In this case, like they have like support for these kind of features. So that's about it. And it keeps counting the turn so that it can like look at the condition, and then it'll respond to the user. And this is the approval function. So it just like asks in the terminal if the user is saying yes or no. Let's go into models.py. This is where we have defined like two of our structured needs. One is the source type URL snippet. The other one is the answer, citations, confidence for the final answer. That's where the final answer pretty much looks the same in both the cases because we have asked for it in a certain format. And this is your run.py file, which is pretty much the same as BAML. It's just like, again, like temporal, how it runs, and without temporal, how it runs. So let's go back to our terminal, explore how temporal works and what is temporal. So basically think about it this way. Let me show you the loop again. Okay, if a user asks a question and the LLM chooses in its decision making that I have to query the internal DB, and maybe it's a Friday. The agent asks the user, but it's a Friday and the user has left for home already. So the user would come back on Monday and would want to give the approval. And you might think this is so stupid, like we can just start the run again. But like think about cases where the agent has run through like multiple steps, and every time the agent runs, it costs. It could be like a lot of tokens it has run through, and we want to save the agent state till that condition. And if the user gives approval or not, whatever the user says, based on that we'll basically save the state till that condition, and then rerun the whole flow, copy our whatever the outputs till now were from all those tool calls before this condition, and just like copy paste them, don't rerun them so that it doesn't cost us, and then like take this condition into account and like continue the whole process. I hope that makes sense. So basically like we are saving them in a DB. We're not running all the iterations that happened before this condition came and it was stopped because the user was away, right? And it could be stopped for like 24 hours, a month. It should be able to continue from where the user had left it. This is what temporal is meant for. Temporal library just supports this use case, and it's pretty amazing. With Pydantic AI, and why I wanted to use it in this scenario was with Pydantic AI, they have integration with temporal, so it isn't a lot of code that you have to write when you're using temporal. While with BAML, you have to define all the actions and how it should be saved. Let me go back and run a query with temporal. So I have the temporal server running right here. I don't want to write the query, but yeah, so this is here I have put the flag for temporal. So it's pretty much the same flow. It'll come and ask me for approval. So this was a query in which it has to look through the internal DB, and that's where there's a human in the loop. And I'm not going to respond. And let's go to our temporal dashboard. Let me refresh this. You can see there's a process which is running. You can go inside. You can see, so at the bottom on the x-axis, you can see like the time is increasing and it's waiting on us. And this is what has happened till now. So it's pretty detailed, like this was the query that went in. You can see that results will appear upon completion. So if I go back now and if I say yes, you can see it was approved. It's going to query the DB and it's going to respond with chat, and it has responded. And this is the response. So it's temporal is pretty cool. I love it. And you can see like how it happened in this order, and the response got to the user at this timestamp. And these are all the steps that happen. Let's do the same thing with Pydantic. I think I don't have I'll just put the flag here. So the agent has decided the topic is product, and I'm gonna say, let me go back and let's look at the workflow. It should have been added. So you can see the Pydantic one. So it defines an ID and it's waiting on us right now. So let me say yes, and let's go back. So resolved query internal DB, and then using the OpenAI GPT 5.2, and this is the answer. Yeah. So you can see it's the same answer. It just logs and shows you everything that has happened. And yeah, I showed it to you pretty quickly. Like I said yes very quickly, and it showed you what happened. But like with temporal, you can like leave it running for however long you want, and you can continue from right there. And you don't have to worry about the previous steps. If they are not dependent on the time, it would just like get the same out. It would save output of each action, and it'll just like get the same flow in and continue from where it was left. Let me show you the code as well. So this is the temporal workflow for Pydantic AI. This is what it looks like. Pretty simple. While in BAML, this is the temporal workflow. So you would see in BAML, like we have defined each activity. That's the difference. So you have to define each of the activities. And I wanted to show this to you, like I mentioned this earlier, our internal docs for the internal DB, why it gives you the topic. So like each document has a topic. So based on your query, it figures out like which topic I have to query in the DB. That's what the topic was product all this time. Yeah, I think this is it for this demo. I just wanted to add more details in. Look through this web page. It's very organized. It has a lot of examples. It explains to you everything, all the differences. And like you can choose either of the frameworks. They're both amazing. It's pretty simple to integrate, temporal, very reliable. I've seen companies do well with either of them. It just depends on what your company is already using and what kind of support they need. Yeah. So I'll stop there. Thank you.